Okay, you will have just been looking at these two photographs and considering the possible factors that explain why there is a different amount of water in these two rivers. And of course, the main factor by why the photo on the right-hand side has more water in it is probably because it has rained. And therefore, rainfall is the principal reason, probably the only reason, why rivers rise and fall. There are actually other factors, but let's just, for the moment, consider rainfall. Now, one question that we have to answer, if you look on the right-hand side, you'll notice there's no clouds in the sky. So clearly it's not been raining recently, otherwise there would be clouds in the sky. So why has the river got so much water in it? And we're going to explore a range of different factors that can help us understand why rivers increase in their discharge. Now, if you remember, the discharge is the amount of water in a river passing a single point every second, and it's measured in this thing called cumex. Now, if we have a look, for example, in the right-hand side, this photograph here, we can see that the river's got a lot more water. It's got a lot higher discharge because there's a greater volume of water passing a single point on the river every single second. However, the reason why is not necessarily just to do with rain. We have to start exploring the surrounding landscape to start to understand why this river here, which is actually the same as this river over here, actually has a greater discharge. Now, what you might want to do is start by reading the physical factors which can affect the discharge of a river. So the physical factors, these are to do with the natural landscape factors that have an influence or have a role to play in how much water is flowing in a river at any given moment. And the first thing you'll obviously understand is that rainfall is the key factor. So we're not really interested in trying to explain why it rains here. We're just interested in what the rain does when it hits the landscape. The first thing you have to understand is the majority of the rain that hits a landscape does not land in a river. It lands on the landscape that surrounds the river and makes its way towards the river in a number of different ways. There are a range of factors that are important to consider, and these are what I'm going to focus in on. So we have size and shape of the drainage basin, the surrounding relief or the gradient of the land, the drainage density, the geology of the rocks in the surrounding landscape, the temperature, the type of soils and the depth of the soils in the surrounding landscape, and probably most importantly, the vegetation cover in the surrounding landscape. Now you can have a quick little read of that or just continue to follow my lesson, because what we're going to be doing is answering this exam question. And as I go through each idea, you are going to want to describe the idea. So describe the physical factor which influences the discharge of the river, and then explain, which is the second part of this question, how it is influencing the discharge of the river. So what role is it playing in causing the river to rise? Okay, and type your answer into this space here. So let's get started with the main part of this lesson. Let's have a look at each of the factors in turn. So the first one we have here is size and shape of a drainage basin. And we can see a river. This is called the River Don. It's in Aberdeenshire. And it flows through Aberdeen, which we can see here. And it's got quite a small drainage basin. It is quite a small river. And a drainage basin is the area of land, which I'm indicating here, which surrounds the river, on which rainwater lands and moves towards that river. So the area in red that I'm indicating here is what we'd call the watershed. And it's the dividing line between this river and the other river. And therefore, any water that lands here will end up, or here, or back here, will end up flowing into the main river channel, which I'm indicating here. Now, in a small drainage basin, there's a relatively small amount of land to capture water, and therefore, when it rains, a relatively small amount of water will end up in the river because it has a small area surrounding it. In the world's biggest river, the Amazon, well, it's got the world's biggest drainage basin, which covers half of Brazil almost, which I'm just indicating here. And therefore, water falling anywhere within this area inside it is going to end up draining into the main Amazon River channel, which is marked here. Now, obviously, if the Amazon's got a much bigger drainage basin, then it can capture a lot more water, and therefore the river will rise much higher because it's capturing a lot more water. So that's the size of the drainage basin. What about the shape? What role does the shape of the drainage basin play? Well, you'll notice the River Don has quite a skinny drainage basin. It's quite narrow, and therefore water never has far to travel to get to the main river. So the distance from the edge or the watershed down to the main river is relatively small. So a narrow and long drainage basin, water is quite quick getting to the main river channel. We can see this shown in this diagram here. A narrow, thin drainage basin, water will normally get quite fast because it doesn't have a long distance to travel. In contrast, if you have a very large, wide drainage basin, which we can see here, well, water can take a long time to come from the back of the drainage basin to get to where we might be standing measuring it, which could be down here, where I've just indicated. So large, wide drainage basins, water takes a lot longer to get to the main river channel, and therefore the river's likely not to rise as fast. Okay, let's have a look at another idea, the relief of the landscape. And here we're really talking about the gradient. So in this photograph, we have two rivers. There's a river here, and there's our river in this photo. Because the landscape is very steep, water will travel down that steep gradient very fast and therefore arrive at the river quite quickly. In contrast, because this flat landscape is very flat, water takes a lot longer to travel across a flat landscape because it's a flat gradient, and therefore if water lands on that landscape, it's going to take a long time to get to the river. So the gradient of the surrounding landscape is going to influence how fast water gets to the river. Right, let's have a look at a new idea, drainage density. Now this is the number of streams in a drainage basin. And we can see in our first drainage basin here that we have the main river channel in the bottom of our valley, which I'm indicating here. But there is a massive network of tributary streams covering the entire landscape. Therefore, water landing anywhere on this landscape, which I'm indicating, will never have far to travel across that landscape to get to the nearest stream, and therefore it will end up getting into the main river very quickly. In contrast, our second river over here has a low drainage density. What this means is the landscape is covered by relatively small numbers of tributaries. Therefore, water that lands on this landscape, for example here, has got quite a long distance to travel before it gets to the nearest stream. And therefore, if a drainage basin has got a relatively low number of tributaries, or what we would call a low drainage density, then it's very likely water is going to take a long time to get to the river. And in contrast, if it's got a high drainage density with lots of tributaries, water will get to the main river very fast. Right, the type of geology on the surrounding landscape. So what's the rock surrounding the river? How does it play a role? Well, if water lands on a rock that is very absorbent, or what we would call permeable, the rock will soak that water in, and water will take a long time to make its way through the rock before getting to the river. However, if the rock is impermeable, which I've just written there, then it will not absorb rainwater, and the water will just hit the surface and flow down across the surface, and will therefore get to the river much faster. So we're really looking at the absorbency of rock, and if a rock is very absorbent, it will soak up a lot of water like a sponge, and it will therefore take a lot longer for water to get to the main river. Where if it's impermeable, then it will take much longer because the rock is absorbing the water. Right, soil depth and soil type. Let's deal with depth. Now this idea is very similar to soil rock type because soil, like rock, absorbs water. So if the soil is very porous, then it will absorb huge amounts of water like a sponge, a bit like the rock as well, and that water will be held in the soil and build up. If the soil is very non-porous, That means most of the water cannot get in and it will stay on the surface and it will flow quickly towards the river. Now, whether the soil is porous or non-porous is influenced by whether it's got lots of sand in it. If it's a sandy soil, it will be very porous because sand particles are quite big and they allow water to flow in. If the soil's got lots of clay, it'll be very non-porous. I've been spelling the word porous wrong there. It's P-O-R-O-U-S. Soil depth is also important because a deep soil can absorb a lot more water, whereas a shallow soil that's only a few centimeters deep can't absorb very much. And therefore, if a soil can absorb a lot of water, either because it's deep or because it's got a high absorbency level, then water's going to take a lot longer to get to the river. Right, let's move on to our next idea. And this is the most important idea, the final idea. How does the vegetation coverage influence the discharge of a river? Well, if we look at the right-hand side photograph here, we can see that rainwater is going to land on this canopy of trees. And the leaves are going to capture that water. They are going to intercept the water, which is a technical word. And that water will be channeled to their root systems. Those plants will then absorb a lot of that water. And therefore, a lot of water that lands on this forest will never make its way to the river because it's actually absorbed by the root systems of the trees that are growing. It's also slowed down because the leaf systems of those plants actually halt it getting to the earth and will slow it down. If we look at this photograph, we can see there's very little vegetation. Therefore, all of the water is falling directly on the grass, which then soaks into the soil, and it will travel much faster to a river. And that's because there's less vegetation to intercept the river, and there's less of a root system in those plants to then absorb that water. And therefore, most of the water that falls on this landscape here is going to end up flowing pretty quickly into the river. Right, so we've explored a range of ideas. You should have been, hopefully, as you've moved your way through this answer, using each idea to describe the factor and then explain the factor. How does it work? How does it influence the discharge of the river? Good luck.